sections 9.6. We are getting to the end of chapter 9, so now we're going to start putting things together that we've been doing all along. So now you're going to use your translations, reflections, rotations, and dilations and do multiple things to the same shape. Okay? So try to keep track of everything. Colored pencils are really helpful at this point. All right, so let's go through a little bit of review on a translation or on anything for that matter. What is the beginning figure called? And this is vocabulary, so you should be able to do this. It's called a pre-image. Before we do anything to it, it's called a pre-image. The end result is called the image. This is after we do things. This is the one that we write the coordinates for. And then what is an isometry? This is where the pre-image is congruent to the image. Remember that symbol means congruent. So an isometry is where the pre-image is congruent to the image. Alright, so let's do one just to make sure we know what we're doing. So we'll put this on the graph first. L M N. Alright, and we're going to slide it under the rule x minus 7, y minus 1. So x minus 7 means we go to the left. Y minus 1 means we go down. So everything goes left 7, down 1. So we'll go 1, 2, 3, 4, 5, 6, 7, down 1. There's L prime. 1, 2, 3, 4, 5, 6, 7, down 1. And then 1, 2, 3, 4, 5, 6, 7, down 1. Alright, so that entire shape shifted left 7, down 1. And we want to put our final coordinates. So L is at 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, negative 13, negative 2. N is at 6, 7, 8, negative 8, negative 2. And then M is at 8, 9, 10, 11, negative 4. Negative 11, negative 4. Okay? Just a quick little review. Alright, what if I give you the picture and I say write the rule? So let's get our rule set up. We put X, Y, and then the arrow, and then we're going to put our rule. We start with the dark purple one. We go to the light purple one. So let's look at the D's. So D goes from here to here. Okay? So it goes to the right 1, 2, 3, 4, 5, 6, 7, 8, 9. If it moves to the right 9, that's X plus 9. And then it moves down 1, 2, 3, 4, 5, 6, 7, 8, 9. It moves down 9, so that would be y minus 9. So there's our rule. This is what a translation rule looks like. Alright, next round. What does a reflection look like? Hopefully you did this morning, but you probably looked in the mirror. So a reflection is like a mirror image. It has to be flipped over. It's reversed of what you're looking at. Alright, so let's put this triangle on the graph. Here's X, Y, and then Z. I think you've done this one before. Alright, and it says to flip it over the x-axis. Well, the x-axis goes horizontally. So we're going to flip everything down. So x prime is right here at 0, negative 1. Y prime goes 3 to the line, 3 to the cross. So this is 2, negative 3. And then Z goes 4. So we go 4 down. So that is negative 3, negative 4. New coordinates every time. Alright, a square. Here's A. Here's B. Here's C, and here's D. There's my square. Alright, and then it says to reflect it over the line y equals x. We've had a lot of discussion about that line, y equals x. Remember, that's the line that goes through the origin and has a slope of 1. So I'm going to start my line right about here. And it goes through the origin with a slope of 1. Okay, you can also see what it's doing to our square at the same time. It's going to run on the diagonal of the square. So A doesn't change places, so it's still at 1, 1. And C doesn't change places because it's on the line also, and it still stays at 5, 5. What happens to B and D? If B is 2 diagonals away from the line over here, it's 2 diagonals over here. It takes D's spot. So B prime is now 1, 5. And then D does the same thing. It goes over here. So D prime is at 5, 1. So this square just kind of spun on its diagonal. And that can happen. But you see why we label the points, because otherwise we wouldn't have known what it looks like. Alright, next thing. Three things that a rotation has to have. One thing has to have a center of rotation. Normally for us that's the origin, but it could be anything. 2, it has to have an angle. I have to know how far to rotate it. And the third thing, we have to have a direction. We need to know clockwise or counterclockwise. We go counterclockwise unless specified otherwise. Alright, there's 2 ways to do it. We can do it by construction, and that's kind of a pain, so that's why we haven't done that. And there's by coordinates, and there's rules for those. You can also turn your paper and just rotate your paper and get the coordinates that way. Alright, so we're going to take this and we're going to rotate it 90 degrees clockwise. So it's going to rotate down into the 4th quadrant. So, see how this one's 1.5, 4? It goes 4, 1.5. Alright, that's that one. I'll color code all of these. This point right here is 3 over 1 up, so it goes 1, 3. This point is 7 over 1 up, so it goes 1 over 7 down. Over here, this is 7, 8, 8.5 up 4, so we go 4 and then down 8.5. 4, 5, 6, 7, 8.5 right here. Alright, this point right here. This would be 7 and then up 2, 3, 4, 5, 6, 7. So, still 7. And 2, 3, 4, 5, 6, 7. And then this one is over 3 up 7, so it would go over 7 down 3. Alright, and there's your shape. Color coded and everything. I'll let you put in the coordinates, because you're good at it at this point. Okay? But see how it's spun? You can see the colors and how it's spun. Alright, for this one, let's do the same thing. So it says rotate it 90 degrees counterclockwise, then 180 degrees clockwise. So let's picture this for a minute. 90 degrees counterclockwise would be this way, right? So it'd be right here. And then 180 clockwise would be right here. So that's just like a 90 degree clockwise if we put the 2 of them together. Okay, so let's just do a 90 degree clockwise because that's how it happens. Alright, and we'll color code these again. So this one is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, down 2. So it goes 2 up 10. 3, 4, 5, 6, 7, 8, 9, 10. Right here. Okay, I'll grab a new color. This one down here is over 10, but it's down 2, 3, 4, 5, 6, 7, 8, 9, 10. Over 10, down 10. So 2, 5, 6, 7, 8, 9, 10, and then up 10. Right there. And then this one right here is over 4, down 10. So it goes over 10, up 4. And there's your triangle. Right there. Rotated. If you go 90 degrees counterclockwise and then 180 clockwise, it ends up being a 90-degree clockwise rotation. Alright, let's review a reflection. This is one that we haven't done yet, and it's kind of crazy. We're going to take the triangle. There's A, and then B is at -5, 1. And then C is at -2, 4. There's my triangle. We are gonna reflect it over the line y equals x minus 1. So you have to graph this line first. And to graph this line, you have to start at -1, so we go down 1. And then the slope is 1, so you go up 1 over 1 like this. There's your line. So let me draw that line. This is our flip line. We can flip it over whatever line that they give us, but this just happens to be the one we give. So A is one diagonal, so we go one diagonal right here. So that's 2, -1. C is 1, 2, 3.5 diagonals, so half, 1, 2, 3. C prime is right there, that's 5, -3. And then B will go 1, 2, 3.5, so half, 1, 2, 3, right there. And that would be 2 and -6. There's your triangle. So if you looked at this with the line going directly in front of you, you could fold the paper on the line and those two triangles would match up. Okay, some theorems to go through. These are kind of quick theorems, but they're kind of important as well. First one, a translation or a rotation is a composition of two reflections. So it's saying if you have a translation, you could flip the shape twice and get the same result. Or a rotation, you could flip the shape twice and get the same result. Second one, a composition of reflections across two parallel lines is a translation. So say you have two sets of lines here. We'll draw parallel lines. And you take a shape and flip it across there twice. So let's say I have the letter E. And I flip it. So it went from here to here. And then it went from here to here. It would flip it back. Oops. Like that. It's the same thing as if I would have just slid it over. Alright, third one. A composition of reflections across two intersecting lines is a rotation. So let's say I have two lines like that. And let's say I have the letter A. So if I reflect it across that line, I get a letter A here. And if I reflect it here, so I went from here to here and from here to here. Those are two flips. It's the same thing as if I would have rotated it 180 degrees. Alright, and the fourth one, the fundamental theorem of isometries. There's a lot of fundamental theorems of a lot of things in math. This one just happens to be of isometries, where the preimage and the image are congruent. So in a plane, you can take one figure and map it onto the other. You can move it onto the other by a composition of at most 3 reflections. So I can take one triangle from one side of the graph and I can flip it no more than 3 times and get the other shape. Alright, a new definition. This is the fourth isometry. It just composes 2 different movements. It is the composition of a glide, or a slide, if you will, is what we've been calling it, a slide, and a reflection across the line parallel to the direction of translation. So if your shape slides to the right, your shape flips up and down. If you slide down, your shape flips left and right. If you slide diagonally, your shape flips diagonally. Alright, so let's try this. It says find the image of text, triangle text, for a glide reflection where we go x, y minus 5, and then the reflection line is y, or x equals 0, sorry. So if we start with this, x and then y minus 5, that means we shift the whole shape down 5. Okay, so we go 1, 2, 3, 4, 5. There's x. And then here's E. And then T comes 1, 2, 3, 4, 5 right here. Okay. And then the reflection line is x equals 0. So x equals 0 is the y-axis. See where colored pencils would come real handy right now. 5, 3. So text moves over here. This is T double prime. 5, 3. And then E comes right here. E double prime. 2, negative 4. And then X, 1, 2, 3, 4, 5, 6. 3, 4, 5, 6 right here. X double prime would be 8, negative 4. For these, I want the final coordinates. After you moved it both times, I want the final coordinates. Alright, same triangle. I'm going to do x plus 1, comma, y, and then the reflection line is y equals negative 2. So x plus 1 means it would just shift to the right 1. And then the reflection line is y equals negative 2. Well, there's the reflection line right there. Okay, so x comes here. X double prime is now 3, 4, 5, 6, 7, 4, 5, 6, negative 7, negative 6. And then E comes here. E double prime is negative 1, negative 6. And then T, way up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, all the way down here. T double prime would be negative 13, negative 4. Or, sorry, I got those backwards. Got ahead of myself a little bit. Negative 4, negative 13. There's our triangle. Okay, 2 movements is what we're doing. Alright, so the question is, would the result be the same if you reflected first and then translated it? So go back and look at your shapes, and I'll ask the question, you can give me your response. And then this is probably a big one. This is probably going to be on your next test. I can almost guarantee it. There are only 4 isometries: a reflection, translation, rotation, and glide reflection. Dilations are not an isometry because they change size. Therefore, the pre-image and the image are not congruent for those. Okay? These 4 are the only ones that keep the same size, same shape.